In this lecture, we are going to talk about what is sigma in Six Sigma and what is 6 in Six Sigma. When I started learning Six Sigma, this was the first question that I had. What is the 6 and what is the sigma? Can the 6 be any other number? And what is the sigma? So it's quite natural that you would have similar questions as well. So what I'm going to do in this lecture is to deep dive and give some clarity on what is this 6 and what is this sigma. If you're not a math student, you don't have to worry. The concepts here would be covered again in greater detail in one of our later lectures. So let's now jump into the lecture. Let's assume that you commute to office by train and your train normally arrives in the station by 7:45 a.m. and you reach there a little bit ahead of that time, and you notice that every day there is a little bit of variation in the arrival time of the train. So some days the train comes a little ahead of 7:45, some days a little behind 7:45. So there's a variation, and that variation is what I am depicting in this graph with those dots. So every day I'm collecting the data of arrival times, and when I cumulate all this, it forms a distribution which is called as a probability distribution. This probability distribution helps us to understand the variation which is there in the process. Now the concept of probability distribution itself would be covered in greater detail in one of our later sections. So if you don't understand that, you don't have to really worry. The sigma which is there in Six Sigma is nothing but the standard deviation, and that standard deviation is nothing but a measure of this variation that we are seeing in this arrival time of the train. How do I represent that? In statistical terms, standard deviation is nothing but the average distance of all the points from the average or the mean of the overall process. So the line that you see in the middle is the grand average of the whole process. So I collected data, let's say for a month, and then I have 25 data points and I take the average of that, and that average is the middle line. Now I'm trying to find out the average distance of each of those points, each of the individual days arrival time from the grand average of that particular month. When I find that value, that represents standard deviation. Let's go a little deeper to understand that. Let's say two scenarios. Scenario 1 where your standard deviation is low. Scenario 2 where the standard deviation is high. When the standard deviation is low, naturally it means that the train arrives mostly around 7:45, which is the target time for us. As a result, the curve looks much steeper and the base of the curve is very less. On the contrary, if the standard deviation is more, it means the dispersion is more, which means the time of arrival of the train varies largely from one day to another, and that is represented by a large base of the curve and the height of that curve also being a little shorter. It's quite intuitive that we always expect the train to come mostly around 7:45, so lower the standard deviation, better it is. In other words, lower the sigma, better it is. In statistics, we use sigma, the Greek letter sigma. Now we understood what is standard deviation in a nutshell. I'm reiterating that these concepts will be covered in greater detail with formulas and all that stuff in the subsequent lectures. But I want to give you an intro right now into the topic, and that's why I'm talking about this here. Let's now move on and talk about what is this 6 in Six Sigma. Let's assume that you reach the railway station by 7:30 a.m. and you wait till 8 a.m. Reaching the station before 7:30 and waiting beyond 8 is something that you don't want to do. So your window of tolerance is 7:30 to 8 o'clock. Let's now take two scenarios, scenario A and B. In scenario A, the variation, or in other words, the standard deviation of the process is very less. It's only 2.5 minutes. If I start stacking 2.5 to 7:45, which means if I start adding 2.5 to 745, I will be able to pack 6 2.5s from 7:45 to 8 a.m. As you see on the screen, I can pack 6 standard deviations between the target time of arrival of the train and the tolerance, the upper tolerance or the upper limit of your waiting time. I can pack 6 standard deviations. Similarly, I will be able to pack 6 standard deviations on the lower side as well. That is between 7:30 and 7:45. This is what we call as 6 sigma. If I am able to pack 6 standard deviations between what the customer wants and my center, that is called as 6 sigma process. This 6 here is called as sigma capability. While sigma itself is standard deviation, the number 6 that you see is nothing but the sigma capability of the process. Now let's go to the scenario B. In scenario B, the variation of the process is more. The standard deviation or sigma is 5 minutes. So how many standard deviations can I stack between 7:45 and 8 a.m.? As you see, we can stack only 3 standard deviations between 7:45 and 8 a.m. So the sigma capability of process B is 3 sigma. Now it's very obvious that the 6 sigma process is more efficient than the 3 sigma process. Just simply because in the case of a 6 sigma process, the chances of the train arriving beyond 8 o'clock or before 7:30 is very remote. It's not likely to happen. But in the second scenario, it's quite likely that the train would come either after 8 o'clock or before 7:30. And that's not a reliable scenario for you. As a result, higher the sigma values, better it is for us to predict the performance of the process. And that is why organizations are trying to improve the sigma value of the processes, because they will be able to give predictable performance to their customers. So that in a nutshell wraps up the concept of sigma and 6 for us. Now, what does it mean to be at 8 sigma? What does it mean to be at 4 sigma? And all that stuff is covered in the subsequent lectures. This is meant to give you an overview about 6 sigma by deep diving into the concept right away, rather than giving you theoretical concepts and then getting into this. If you feel this is slightly heavy and if you have not understood this, you don't have to worry. All you have to do is to stick on to the schedule, look at the subsequent lectures, and you would surely understand the concept better. Thank you.